So we're saying these are simply functions. These are functions denoted by letter P, whose power, so the highest power you ever see is always going to be greater than or equal to a 3. That's only time we say it's a polynomial, except if it's not 3, if it's 2 or less, we know 2 is a quadratic, 1 it's a linear. So we always call polynomials to be functions that start with the degree of x being equal to 3 and above. And the degree of x will tell you how many solutions you are going to expect if you get what? If you get to solve it. So the first thing I'm going to teach you is how to factorize a polynomial. So this will be borrowed from your tutorial sheet number 4. Yeah, so here they are simply saying this I'll use this question here, question number 6. So they've given us this guy here to say factorize. I want us to factorize it completely. So this is, I'll give you an example on how you can factorize your polynomials. So the polynomial is given to be, okay, so my board, so it's given to be 3x to the power 3. Then you have minus 14x squared, then minus 47x. Then the last one is just minus 14. Okay, so let me try to write this properly. So the last number that you are given, which is your constant, in this case it's negative 14. So the negative 14 is going to help us to factorize the polynomial completely, and you look for numbers that can divide 14 without leaving a remainder, and those possible factors of 14 are just going to be plus or minus 1, there's a plus or minus 2, then there's a plus or minus 7, then there's a plus or minus 14 itself. So these are all the numbers that can possibly factorize this expression that you're having here. So now I'll start with 1. So we're going to say, what is f of 1? It's a trial and error method. Yeah, that's how we factorize polynomials, is trial and error. So you look at your 1, you put the 1 here. So we're saying when x is equal to 1, so I'm trying x is equal to 1. If I put 1 everywhere here, is it going to give us a 0? So you are just able to see from this to say this is not going to be a 0. You don't even have to go further because you don't have a calculator. You can't waste your precious time to cross-check when you can just see that it cannot be a 0 because you have negative, negative, negative throughout. Then you try negative 1. If we try negative 1, this is just going to be this. Let's check if this can give us a 0. So this will be negative 3, this will just be negative 14, this will be positive 47, then this side is negative 4. So can this guy give us a 0? Is this possible? Just by looking at this here, you may, is this going to give us a 0?
A 0.
No, it cannot, right?
Yes.
So we have already used this. We have used this first part, the first factors. We have used this. We got the second one. We check out 2. So I'm going to start with positive 2. If I start with positive 2, meaning I'm having 2 to the power 3, minus a 14 with a 2 to the power 2, minus a 47 with a 2 there, then minus a 14. So is this going to give us a 0? So we're just going to have 3. This is 8. Then this is going to be 14 with a 4. This is just a 47 with the 2 minus 14. So here you have, this is going to give us what? This is a 24. Then this is minus what? Minus 97. Then this is going to give us minus what? If you are using this. So even without solving, you're able to see this is going to give us minus 14. There's a 5 there. Already this is not going to give us a 0. So we skip this. We go to the next value, which is negative 2. It will be 3, negative 2 squared, then minus 14 with a negative 2. Then we are having a what? We are having a negative, a 47 with a negative 2. Then there's a negative 14. This will be negative 24. This will just be, there's a 4 there, 4 by 4. we're having, this is going to give us what, 64, if I'm not mistaken, 64. This will give us positive what? This is going to be that remainder 1. This is going to give us 97. You have this. If you check, this should give us a 0, I think. If you check this, because you're having a 24, then you have a 14 and a 64. This is going to give you what? Is this true? Because 2 by this is just 14. So it's supposed to be a 4 here. Is it? What is 47 by 2? What do you get?
You get 94.
You're getting a 94. Then if you add this 3, what do you get?
Alright. You get 102.
102. Okay, so this is still not going to give us, this is 90 what? Or maybe I've made a mistake. Let me just try to redo it. Yeah, so here we're saying x is equal to negative 2 has worked. It simply means that x, when you take the 2 back, you're going to get x plus 2. We're saying this is a factor. So this is a factor of the polynomial. That's what we've gotten. That's what we have gotten. So
why do we use x?
Because the function, the polynomial, is in terms of x. Yeah, because it's in terms of x, right?
Yes.
Because where there was x, that's why we put negative 2. So when x is equal to negative 2, that's the only time we got a 0. So no wonder we are replacing, rather, that's why we're using x. Yes.
Okay. That's why the 2 becomes positive as well.
Yes, because when we take it this side, because here it's x is equal to negative 2. When you take it back this side, that's when it becomes x plus 2.
Yes.
So now, if you're okay with how we get our first factor, the first factor is always gotten using trial and error method. So once you get your first factor, which is x plus 2, you can now decide to use long division or synthetic division to break down your big polynomial into smaller portions. So we're saying the polynomial that we are having, we're going to divide it by this guy, which is called our divisor, our x plus 2. This is going to give us what we call your quotient plus a remainder. That's what we say. It's like, remember that thing you are doing in high school, or rather primary. If I give you 15 divided by 2, this will give you 7, plus the remainder is what? The remainder is 1, right?
Yes.
So the remainder is it not? Yeah, it's 1, so that if you get to multiply, how do we write it? Yeah, we say something like 7.5. Yeah, because this is going to be 1, so 1 over 2. So we're just going to say 15 can be written as 7 by 2, then plus 1. In short, we're just saying our polynomial can be written as the divisor multiplying the quotient, then plus the remainder that we have. And whenever the remainder is 0, so this is the format that you can also rewrite your polynomial in, where, let me emphasize this, where p of x is the polynomial, the original thing. That's what you have. Then d of x is the divisor, the one you are using to divide. Then you are having r of x, this is the remainder. This is what you have. Then the q of x is what you call your quotient. So quotient is what you get, like your 7. 2 into 15 is 7 plus half. So this is our quotient. This is the polynomial, this is the divisor, then this is the remainder this side. So we're just saying we can always write your expression like this, and I'm going to teach you how to use long division. So we're trying to factorize it completely, and we have only found one factor. So now we're going to use long division to break it down. So we're going to put our x plus 2 here, then we're going to put the whole polynomial here. This is 3x to the power 3, then minus, it was a 14x to the power 2, minus a 47x, then minus a 14. So you notice that the values of x are properly descending down like this. 3, 2, 1, then the constant. If there was anything missing, you would have used, for example, if I give you x to the power 3, then plus 2, and I say put it under this, you would have written it as x to the power 3, then you say x. This, you say 0x, and you write your constant. You've seen what I've written here, right?
Yes.
We need a place value of every coefficient of x, every x term. So this is what I was trying to say. And the reason why we are getting the remainder to be 0 is simply because this is going to be a factor. So on dividing, whenever you are dividing, you only use the first letter, which is x, the first thing here. This is the only thing that you use to divide. So we're going to say x into 3x squared, 3x cubed. This is going to be 3x squared, right?
Yes.
Then now, on multiplying, we multiply both of these terms here by the guy which we've gotten there on top. So now we say x times 3x squared. This is going to be x to the power 3. Then 2 times 3x squared, that's simply going to be plus a 6x squared. Then we write something like this. Then we say minus. Always we subtract. Then is this okay when I say you're going to get a 20x squared?
How did we reach 20x squared?
Negative 14x squared minus your 6x squared. That's how we're getting
Okay.
it. Yeah, so this part here goes away. It gives us a 0. Then we bring this guy down. This is going to be negative 47. Then x. Then again we divide with x. X into negative 20x squared. This is just going to be negative 20x. Then again we multiply this by negative 20x. That's going to be negative 20x squared. Then minus your 40x. Then again we subtract.
Not
here.
47.
No, we multiply with a number which is on top. So 47
okay.
came down. Then to get these guys here, we are multiplying these two guys here by the number which we've put here on top.
Yes.
Yeah, so x times negative 20, again 2 times negative 20. Yeah, so then we find the difference now. This will disappear. Then negative 47 minus negative 40, that's simply going to give us a negative 7x, right?
Yes.
Then you bring the 7 down here, the 14 down there. Then again you say, we divide this, we're going to say, what is x into negative 7x? That's just going to be a negative 7. Then again, we start multiplying these two by the negative 7 there. That's going to give us a negative 7x, then a minus 14. You notice that if I find the difference here, if I subtract, I'm simply going to get a 0. The main reason why we're getting a 0 is because this was found to be a factor of our polynomial. So that's the reason why the remainder is a 0. This is called the remainder theorem. The remainder theorem is whenever you can substitute your linear factor. Whenever the divisor is a linear expression with x having the highest degree to be 1, you can just solve this. When you solve this, it gives you negative 2. When you put this in the polynomial, the number you get is the remainder that you're going to get if we divide that linear factor into that polynomial. So here the remainder is 0. That's your Rx, that's your remainder. Then this here is your quotient. Then here, this is your divisor, this is your dx. Then this here is your polynomial, which is p of x. So now that you've broken it down, we can now rewrite it. Remember, we said the polynomial is the same as the divisor times the quotient and then plus the remainder. So the divisor is x plus what? X plus 2. The quotient is simply this guy that we got, which is 3x squared minus 20x, then minus 7. That's what we got on top. The remainder is 0, so no need of adding it. Then at this point, you are simply going to break down this part here because this has now become a quadratic, this other part. So now you can break this part using product sum factor. Your product is negative what? 21. Your sum is just negative 20. So what factors can we use?
Negative 7.
Negative what?
I think negative 7 and 3, but I'm not sure.
3x squared, we'll use negative 21 and x and 1. This is what you get. Then this is going to be x plus 2. Then here you can just say 3x, then what remains is 3 minus 7. Then here you just have 1, then you have x minus 7. So now we factorized this into 3 parts. This is going to be that, and also you have 3x plus 1, and then you have x minus 7. So here you have factorized it completely. We are not solving, we are just breaking it down to see the 3 linear factors. So this is what you're going to get.
Okay.
You've seen how I've done it, right?
Yes.
So now we used long division. After you found your first factor by trial and error method, you use it and then you divide the polynomial to break it down to formulate your quotient, which is a quadratic. Then you continue until you have the 3 linear factors. If you wanted, you'd have used the synthetic division, the second method. So synthetic division is, you already got the first factor to be this, right? So when you solve it, when you solve this, it gives you -2. You write your -2 here. Then you come down like this. Then you write the coefficients of your polynomial. So there was x to the power 3, there was x to the power 2, there was x, then there was a constant. So what was the coefficient of x to the power 3? There was a 3. This was a -14. This was a -47. Then this was a negative, is it a -7 or 14?
14.
14, okay. So the last guy is -14 as well. So now you bring the first number here down. This is going to be a 3. Then now you multiply -2 times 3. That's going to be -6. Then you add this, you get a -20. Then you multiply again -2 times -20. That's going to give you a 40. Then here we add, we get a -7. We multiply this, we'll get a 14. The answer there is 0. So this is here is your remainder. Then what you get here on the middle is your quotient. That's your q of x. So you're just going to say your q of x is equal to the polynomials to the power 3. The quotient will be 1 degree less as compared to the polynomial. So this is just going to be 3x, then minus 20x, then minus 7. You break this guy down again. We used product sum factor. You remember we've just gotten this. We're just from getting this. This is what? X minus 7. So these are the 2 factors plus the one that we initially found, which was x plus 2. So you simply write all of them now. This is 3x plus 1, and then you have your x minus 7. Either way, you are factorized completely. So synthetic only works if the divisor is a linear expression like this one, because you need to solve it and get the x term that you're going to put here. Yeah, so this is also called the Chinese method. So synthetic is mostly preferred because it's straightforward.
Now, how do you know that it's linear? Those with x in front, x plus something, or x minus something is linear?
Yes, linear meaning the highest power of x in that question is just like this one here. This is linear, this is linear, this is linear, this is quadratic, right?
Yes.
Yeah, so linear meaning the highest power of x here is 1.
So how do you do it if it's a quadratic? You do the long division?
If it's a quadratic, you have no choice than to do long division.
Okay.
Yeah. So let me show you this, just because we just started polynomial, so we should be able to answer question number 22. So if we start with the first one, they just want us to be able to tell them the quotient and the remainder when we are done dividing. This is the polynomial, we divide it with this. So I'll use long division because most people hate long division. So you just have to be familiar with long division, because if you understand long division, synthetic will be a walkover for you, because you just be using it to confirm your answers. So your number, I'll start with the one that has a quadratic, because we've done something that has a linear. So how about if it's a quadratic like number 4? So this guy here, where we have no choice than to use long division. So our divisor is simply x squared then plus x minus 7, is it? Then this is dividing, the guy we are dividing is x to the power 5, then plus x to the power 4, then we have minus 8x to the power 3, Then the next one is just x plus 2. So we are having, now you notice there is nothing that has x to the power 2 here, right? So we need to write the place value there. It will be 0x to the power that, then plus x, then plus 2. You've seen how I've written it, right?
Yes.
Yeah, because we always need the place value of everything. Yeah, so let me just write this guy neatly. This is x, then plus x minus 7. Then everything this side will just be x to the power 5, then plus x to the power 4, minus 8x to the power 3, plus 0x squared, then plus x, then plus a 2. So we always divide with the first term only. Then multiplying, that's when you multiply with everything. So here, again, in a similar fashion, we're just going to be dividing with the first thing. And when you reach a stage where what we are dividing with is, like here, we're able to divide x squared into x to the power 5, because this is it's at a higher degree. It's going to give us what? X to the power what?
3.
X to the power 3, Then, now we can multiply with everything. This side is going to be x to the power 5, then it's going to be x to the power 4, and minus 7x to the power 3. So, because there are 3 terms on the divisor, it means at every stage, you always need to have 3 terms. So, this will go to give us a 0. Then, this again will go, the x to the power 4 minus x to the power 4. This here will simply go to give us, this is it going to be negative x to the power 3?
Yes.
Then we bring down the plus 0x squared. That's what you get. And because we only have this guy, I'll bring down this again. This is going to be plus x, because we need to have 3 things at every time, at every stage, because here there are 3 of them.
Yes.
So I'll divide x squared into this. This is going to give me minus x. And this is going to give us, this is going to be x to the power 3. This will be x squared. Then this is now going to be plus 7x. Now we decide to find the difference here. So here, this is going to go. This is just going to be x squared. Then this is going to be minus 6x. I can bring down the 2 this side. And then from here, again, I can divide because it's divisible, which is just going to be a 1. Then this is going to be x squared plus x, then minus 7. This will end up just being, if I find the difference here, this will just give us negative 7x, then it is going to give us a 9. So this is a remainder. The remainder is negative 7x plus a 9. I can't continue here because x squared cannot divide negative 7x. Yeah, then our quotient is the guy on top. So we've already given the quotient is this guy here on top. Then the remainder is that one. So this is what we do if you're looking for your quotient and the remainder using long division on a question like this one, where you have a quadratic as a divisor. Is this okay? Is this okay?
I have a question.
Uh-huh.
I heard the rumor that at the end of the year, for the mathematics department, they collect all the tutorial answers you've done to add in the CA. Is that true?
No, they just do that to make they say that, and they even require you to submit to just make you solve, because the exam will be based on the same tutorial sheets. Yeah, so they do that to make sure that everyone attempts and you go through, so that you have no excuse, but you'll be forced to solve. Yeah, to just motivate people to study and revise everything, but they don't add them to the CA.
Oh, but you still have to hand them in. Yes,
you still have to hand them in. So as you are solving, it will be wise that you are solving in a book, so to just keep them in the book.
Okay.
Yeah.
Are you also a tutor at UNZA?
No, not yet. Not yet. I was, but then I stopped, but I'm going to start after my master's.
Oh.
Yeah.
Okay. I understood this part, yes.
This part is okay, right?
Yes.
Okay, so aside from these where you have linear expressions, there is a portion that we call the remainder theorem. Why are you asking whether I'm a tutor, Numez?
Because every time I come for lessons, you always have the tutorial sheets before I do.
Oh. Okay, so the remainder theorem is just a portion where you learn to say, whenever you are given a polynomial, like this guy here, like this one here, number 23, before you even do the other three, they are simply saying, given that x this is a factor, so how can you prove that this guy is a factor? So we just solve the x minus 1. When you solve this, you get x is equal to 1, right? Then you plug this one in the polynomial. So when you plug it there, it should give you a 0 if it's actually a factor. So we have a 1, then square, then plus 22, and a 1 and minus 7. This will be a 2 minus 17 plus 22 minus 7. This will give us what? This is going to be 2 minus 7, that's going to be negative 5. Then 22 minus 17, that's going to be a 5. So this gives you a 0. So we have already verified to say this guy is a factor, and we can use it using synthetic division to find the quadratic. We break it down because they want us to factorize this completely, the same way from doing the other question, the other example that we did. So they want to see 3 factors. By the time you're done solving, there should be 3 of them. There should be x plus b, there should be x plus c. So we're not solving, we're just having, we're just putting it in these 3-factor form. Sometimes you'll find that some factors will be repeating themselves. So in that case, let's say you find x plus a and x plus a, you just write it once and put a square there, then write the third one this side, meaning it's repeating. Yeah, there are those cases. Yeah, so for this one, do you think you can find challenges to divide these first 3 here, these ones here, using synthetic?
I think I can do them myself.
You can do them, right?
Yes, but if I have questions, I'll come back to ask you.
Okay, yes. Okay, then apart from that, that was on number, that was, yeah, that was just the whole part of synthetic and long division. Look at question number 5 here. They are saying, show that when this guy is divided by this, the remainder is what? 5. This is where the remainder theorem comes in. So we're just going to solve this. When you solve it, this gives you x is equal to 1. When you put 1 in the function, the answer you get is the remainder. So when you put 1 in the whole expression, you're going to get 3, put a 1 there. Then you have minus 2, put a 1 this side, then plus a 4. This is going to be a 3 minus 2, then plus a 4. This will be 1 plus 4. This gives you a 5. So x minus 1 is not a factor of this polynomial because the remainder is not 0. The remainder is what? 5.
5.
Yeah, so this is what the remainder theorem does. They just give it to you for you to verify whether something is going to be a factor or not. Yeah.
Okay.
So at least you have an introduction to this thing, right?
Yes, I do.
Okay, so now with what we've done,